In this module, you will learn about the limitations of the mean deviation. You will also learn to define variance. Many times, the degree of variability in a data is high. In such cases, the median cannot be considered as a central tendency. Thus, the mean deviation about the median will not be sufficient. Again, during the calculation of the mean deviation of a data about its mean, we ignore the negative signs of the deviations. This results in the sum of the deviations from the mean being more than the sum of the deviations from the median. Thus, mean deviation about the mean is not more scientific. For calculating mean deviation, we consider the absolute values of the deviations. Thus, we cannot carry out further algebraic operations. Therefore, mean deviation about the mean or median is not sufficient to measure the dispersion. So we need to extend the measure of dispersion to an appropriate measure of dispersion. Variance is such a measure of dispersion. We know that, to find the mean deviation of data, we take the absolute values of the deviations from the mean or median to eliminate the negative sign of the deviations. To avoid the difficulty of the negative signs of the deviations, an alternative is to take their squares. Let's consider n observations, x1, x2, x3 and so on, up to xn. The mean of the observations, x bar, is equal to the sum of the observations divided by n. Now, the deviations of the observations from the mean are shown. The squares of the deviations are x1 minus x bar whole squared, x2 minus x bar whole squared, and so on, up to xn minus x bar whole squared. Now, the sum of the squares of the observations can be written as the summation of xi minus x bar whole squared, where I is running from 1 to n. From this result, we can infer that if the sum of the squares of the deviations is 0, then each deviation is 0. That is, there is no dispersion in the data about the mean, since all the observations are equal to the mean itself. And if the sum is small, then the observations are closer to the mean. Hence, the degree of dispersion is low. If the sum of the squares of the deviations is large, then the degree of dispersion is high. Let's take the mean of the squares of the deviations. This is called variance. The variance of a data is the mean of the squares of the deviations of the observations from the mean. This is denoted by sigma squared. This is the formula used to calculate the variance of an ungrouped data. Similarly, the formula for the variance for a discrete frequency distribution is given by sigma squared equal to 1 divided by the sum of the frequencies, multiplied by summation of the product of the squares of the deviations from the mean and their respective frequencies. The formula for the variance for a continuous frequency distribution is given by sigma squared equal to 1 divided by the sum of the frequencies, multiplied by summation of the products of the squares of the deviations of the mid-values from the mean and their respective frequencies. Let's consider the given frequency distribution table of trees planted in 20 schools in a tree plantation program. We'll find the variance of the given data. To find the variance of the given data, we first need to find the mean of the given distribution. Let the number of trees planted be xi and the number of schools or frequencies be fi. The total number of schools or sum of frequencies is equal to 20. Now, we'll find the product of the trees planted and the number of schools that planted them. The sum of the products of the numbers of trees and the schools is 320. Therefore, the mean of the frequency distribution is 320 divided by 20, which is equal to 16. Next, we'll calculate the deviations of the numbers of trees planted from the mean. Now, the squares of the deviations are calculated as shown. The product of the squares of the deviations and their frequencies are obtained as shown here. The sum of the products of the squares of the deviations and the frequencies is equal to 700. Therefore, the variance is 700 divided by 20, which is equal to 35. Please note that if each item is increased or decreased by a fixed constant, then the variance does not alter. In other words, variance is independent of change of origin. For any arithmetic series, variance is equal to the square of the common difference multiplied by n squared minus 1 whole divided by 12.